Hi everyone. Today, we embark on a journey to uncover one of Earth's most powerful yet invisible guardians, the ozone layer. You might have heard of it as Earth's sunscreen, but there's a deeper, more compelling story waiting to be told. From its groundbreaking discovery by pioneering scientists to the shocking ozone crisis that nearly jeopardized our planet's future, the ozone layer has been a source of both awe and alarm. But what exactly is the ozone layer? Why does it hold such immense importance? And are the myths we've heard actually true? Let's unravel these mysteries in today's video. In this video, we'll delve into the captivating science, the international race to save it, and what it signifies for our future on Earth. Stay tuned, because by the end of this video, you'll grasp just how vital this thin, fragile layer is to everything we cherish and hold dear. This is the ozone layer.
High in the atmosphere, a strange phenomenon was observed. Something was absorbing the sun's ultraviolet rays. Scientists, pioneers in their time, pieced together the puzzle. They discovered a form of oxygen, a molecule with 3 atoms instead of 2. They called it ozone, a rare gas with extraordinary properties. This ozone, concentrated in a specific layer, acted as Earth's natural sunscreen. Their research, groundbreaking at the time, revealed the existence of our silent guardian, the ozone layer, a delicate shield protecting all lives on Earth. But this discovery was only the beginning. Our story begins in the early 19th century. Christian Friedrich Schonbein, a German chemist, was the first to identify a distinct smell during electrical discharges. He named this reactive form of oxygen ozone, derived from the Greek word ozine, meaning to smell. Schonbein's meticulous work laid the groundwork for future atmospheric research. His discovery set the stage for understanding the molecule, though it would take years to grasp its role in the upper atmosphere. Fast forward to the early 20th century, Sidney Chapman, a British physicist, published theoretical models of ozone formation in the stratosphere. His work explained how UV radiation from the sun splits oxygen molecules, allowing single oxygen atoms to bond with O2 to create ozone. This foundational model established our initial understanding of the ozone layer's formation and function. In 1974, Mario Molina and Sherwood Rowland published groundbreaking research in Nature describing how chlorofluorocarbons, CFCs, could reach the stratosphere and release chlorine atoms that destroy ozone molecules. Their research raised alarms about human impact on the ozone layer, leading to policy changes and greater scientific inquiry. In 1985, the British Antarctic Survey discovered the ozone hole, reporting significant seasonal depletion of ozone over Antarctica. This confirmed the alarming depletion of ozone in a specific region, validating concerns about CFC's impact. It spurred international efforts to protect the ozone layer, resulting in the Montreal Protocol's adoption in 1987. In 1995, Mario Molina, Sherwood Rowland, and Paul Crutzen were awarded the Nobel Prize in Chemistry for their contributions to understanding ozone chemistry. Their findings emphasized the critical role of the ozone layer and influenced global environmental policies. Thanks to these pioneers, we now understand the critical role of the ozone layer in protecting life on Earth. Their combined efforts revealed how the ozone layer acts as an invisible shield, absorbing harmful ultraviolet radiation. This groundbreaking research unveiled the silent workings of our atmosphere. It also highlighted the importance of scientific collaboration and perseverance. Thanks to these pioneers, we now understand the critical role of the ozone layer in protecting life on Earth. High above Earth in the cold reaches of the stratosphere, a delicate ballet unfolds. Oxygen molecules struck by the sun's powerful ultraviolet radiation split apart. Single oxygen atoms, highly reactive, search for partners. These lone atoms, in a cosmic dance, collide with other oxygen molecules. A new bond is formed, creating a molecule with 3 oxygen atoms, ozone. This newly formed ozone, a sentinel in the sky, stands ready to absorb the sun's harmful rays. But this cycle, this dance of creation and destruction, is in constant flux. As ozone absorbs UV radiation, it breaks apart, returning to its original form of oxygen. The cycle continues, a delicate equilibrium maintaining the protective shield. For millennia, This natural process remained undisturbed. The ozone layer, our silent guardian, protected life on Earth. But the 20th century brought a new challenge, a threat to this delicate balance. The dawn of the 1970s saw a world transformed by technology. Industries boomed, releasing new chemicals into the atmosphere. Among them, chlorofluorocarbons or CFCs, seemingly inert and harmless, found widespread use in refrigerators, aerosols, and more. Completely oblivious to us, these man-made chemicals were embarking on a journey. Carried by winds, they rose high into the atmosphere, reaching the stratosphere, the realm of the ozone layer. There, they began a silent assault. CFCs, under the sun's intense radiation, broke down, releasing chlorine atoms. These chlorine atoms, highly reactive, acted like a molecular wrecking ball. Each chlorine atom, in a devastating chain reaction, could destroy thousands of ozone molecules. The first whispers of trouble emerged from the icy continent of Antarctica. Scientists analyzing satellite data noticed something alarming. A dramatic thinning of the ozone layer, an ozone hole, was forming over the South Pole. The discovery sent shockwaves through the scientific community. A gaping hole, a region of severely depleted ozone, was growing over Antarctica. The once pristine ozone layer, our shield against the sun's invisible fury, was weakening. Year after year, the hole expanded, reaching an alarming size. Scientists, racing against time, worked tirelessly to understand the cause. Their findings were both groundbreaking and concerning. The evidence was clear: human activity was to blame. Those seemingly harmless CFCs, released into the atmosphere through industrial processes and everyday products, were the culprits. The very chemicals designed to make our lives easier were jeopardizing our future. The ozone hole wasn't just a scientific curiosity, it was a stark warning, a testament to the interconnectedness of our planet and the unintended consequences of human actions. The world watched with bated breath, the future uncertain. The ozone hole, a symbol of environmental crisis, became a topic of global conversation. But with heightened awareness came confusion, myths, and misconceptions. Some claimed hairspray was the sole culprit, others pointed fingers at volcanic eruptions. While volcanoes do release some ozone-depleting substances, their impact is dwarfed by human-made chemicals. The science was clear: CFCs were the primary driver of ozone depletion, and addressing this crisis required a global effort. Another misconception linked global warming to the ozone hole, suggesting a direct causal relationship. While both are environmental concerns, they are distinct phenomena with different underlying mechanisms. Understanding the nuances was crucial. The ozone hole, primarily caused by CFCs, required targeted action to phase out these harmful chemicals. Climate change, driven by greenhouse gas emissions, demanded a separate but equally urgent response. The scientific community faced a critical challenge: to communicate complex information accurately and effectively. This was not just about sharing data, it was about making the public understand the gravity of the situation and the science behind it. Myths needed to be debunked, facts emphasized, and the urgency of the situation conveyed to the public and policymakers alike. It was a battle against misinformation and apathy, requiring clear, consistent, and compelling communication. The response was unprecedented. The world united, forging international agreements like the Montreal Protocol, a landmark treaty aimed at phasing out ozone-depleting substances. This treaty was a significant step forward, showing that when nations come together, they can tackle even the most daunting environmental challenges. It was a testament to the power of collaboration and scientific diplomacy. Scientists, policymakers, and activists worked hand in hand, demonstrating that collective effort can lead to meaningful change. The Montreal Protocol, hailed as a model for environmental action, led to a dramatic reduction in CFC production and consumption. Industries adapted, finding alternatives to harmful chemicals, proving that economic growth and environmental protection can go hand in hand. The results were encouraging, a beacon of hope in the face of a global environmental challenge. The success of the Montreal Protocol inspired further environmental initiatives, showing that progress is possible. The ozone layer, though still bearing the scars of human impact, began to heal. This recovery was a clear indication that human actions, when guided by science and driven by collective will, can reverse environmental damage. The hole over Antarctica, a stark reminder of our capacity to harm the planet, showed signs of shrinking. This positive change was a direct result of global cooperation and adherence to scientific recommendations. The story of the ozone layer, a tale of crisis and recovery, offered a powerful lesson that collective action, guided by science, can make a difference. It underscored the importance of staying vigilant and proactive in our efforts to protect the environment for future generations. Life on Earth, in all its beauty and diversity, exists because of a delicate balance. A balance maintained in no small part by the ozone layer. This invisible shield high above us allows life to thrive. Plants, the architects of our ecosystems, depend on sunlight for photosynthesis. Yet the sun's rays are a double-edged sword. Too much ultraviolet radiation can damage delicate plant tissues, disrupting their growth and development. Our own eyes, windows to the world, are particularly vulnerable to UV radiation. The ozone layer filters out harmful UV rays, protecting our vision from cataracts and other eye diseases. Even our immune system, the body's defense against disease, can be weakened by excessive UV exposure. The ozone layer acts as a silent guardian, allowing our bodies to function optimally. We've all felt the warmth of the sun on our skin, but that same warmth in excess can be harmful. Ultraviolet radiation, a component of sunlight, can cause sunburn, premature aging, and even skin cancer. Skin cancer, a growing concern worldwide, is linked to prolonged UV exposure. The ozone layer's depletion amplifies this risk, making us more vulnerable to the sun's harmful rays. UV radiation comes in different forms. UVA rays penetrate deep into our skin, causing wrinkles and aging. UVB rays are responsible for sunburns and play a key role in skin cancer development. Protecting ourselves from the sun is essential, especially as the ozone layer recovers. Sunscreen, protective clothing, and seeking shade during peak hours are simple yet effective ways to minimize our risk. The impact of the ozone layer extends far beyond human health. It affects entire ecosystems, the delicate web of life that sustains our planet. Phytoplankton, tiny organisms at the base of the marine food chain, are highly sensitive to UV radiation. A depleted ozone layer disrupts their growth, sending ripples through the entire marine ecosystem. Amphibians, with their permeable skin and aquatic life stages, are also particularly vulnerable to UV radiation. Increased UV exposure can lead to developmental abnormalities and population decline in these sensitive creatures. The interconnectedness of life on Earth means that damage to one part of the ecosystem can have cascading effects on others. Protecting the ozone layer is about safeguarding the intricate web of life that sustains us all. The story of the ozone layer is a reminder that our actions have consequences, often unintended and far-reaching. It also highlights the power of science to understand these complex systems and guide our response. The recovery of the ozone layer, thanks to global cooperation and decisive action, is a testament to our ability to address environmental challenges when we work together. But the story isn't over. As we face new challenges, from climate change to pollution, the lessons learned from the ozone crisis remain relevant. We must continue to monitor our impact on the atmosphere, base our decisions on sound science, and prioritize the health of our planet. The future of the ozone layer, and indeed the future of our planet, depends on our collective action. By understanding the science, embracing sustainable practices, and advocating for responsible policies, we can ensure a healthy planet for generations to come. The ozone layer, our shield in the sky, is slowly healing. The hole over Antarctica, once a gaping wound, is shrinking, a testament to human ingenuity, global cooperation, and the power of collective action. The Montreal Protocol, signed in 1987, marked a turning point. Nations united, phasing out ozone-depleting chemicals. The results are undeniable. CFC concentrations are dropping, the ozone layer is recovering, a fragile victory for our planet. But this victory is not absolute. The ozone layer, though recovering, remains vulnerable. Scientists continue to monitor its health, vigilant for any sign of relapse. The echoes of past damage still linger. Full recovery is projected by mid-century, a slow and delicate process. The ozone layer, a reminder of our mutual connection, demands our continued vigilance. The story of the ozone hole is not over. It's a story of ongoing responsibility. As we celebrate the success of the Montreal Protocol, new challenges emerge. Unforeseen threats to the ozone layer demand our attention. The delicate balance of our atmosphere, constantly in flux, requires unwavering vigilance. Emerging ozone-depleting substances not covered by the original Montreal Protocol are on the rise. These chemicals, used in industrial processes and products, pose a potential threat to the recovering ozone layer. Climate change, another pressing concern, adds another layer of complexity. Changes in atmospheric circulation patterns and temperatures can influence ozone distribution and recovery rates. The fight to protect the ozone layer is far from over. It demands continuous monitoring, scientific research, and international cooperation. The lessons learned from the past, our collective response to a global crisis, serve as a guide for the future. The story of the ozone layer is ultimately a human story, one that reflects our deepest connections to the environment. It's a story of our capacity to harm our planet, through actions that have long-lasting impacts on the delicate balance of nature. But it's also a testament to our ability to learn from our mistakes, to innovate, and to take meaningful action to correct our course. It's a story of hope, resilience, and the enduring spirit of humanity. It showcases the power of collective action, where every small effort contributes to a larger global impact. Each one of us has a role to play in protecting the ozone layer, a crucial component of our atmosphere. By making informed choices as consumers, supporting sustainable practices, and reducing our carbon footprint, we can ensure a healthy planet for generations to come, preserving the beauty and diversity of our world. The ozone layer, a symbol of our planet's interconnectedness, serves as a reminder of our shared responsibility. It reminds us that we are all connected no matter where we live or who we are. What we do today has consequences for tomorrow, impacting the lives of future generations. Let us be the guardians of this invisible shield, standing together to protect life on Earth. Protecting life on Earth for generations to come is a noble mission that we all share. The future is in our hands, and the choices we make today will shape the world of tomorrow. Let's choose to protect our planet, to cherish its resources, and to nurture its ecosystems, to safeguard its delicate balance, ensuring that all forms of life can thrive, and to ensure a vibrant future for all life on Earth, a future where nature and humanity coexist in harmony. The ozone layer, a silent guardian high above, protects us all. It's an indication to the delicate balance of nature, a balance we once unknowingly disrupted. Yet, from the brink of disaster, we chose to act. The story of the ozone layer is a story of human impact, scientific discovery, and the power of collective action. It reminds us that our actions have consequences, but also that we have the power to choose a different path. The future of the ozone layer, the future of our planet, rests in our hands. By understanding the science, embracing sustainable practices, and advocating for responsible policies, we can ensure a healthy planet for generations to come. Let us be the generation that safeguards our planet, for ourselves and for all who will follow. Thanks for watching. We hope you enjoyed uncovering the wonders of the ozone layer with us. If you found this video insightful, Don't forget to share your thoughts in the comments below. We'd love to hear from you, and come back for more amazing discoveries about our world and beyond. Until next time, stay tuned and stay curious.